All right, looking at worksheet B for chapter 12. There we go. So we're going to be looking at numbers 3, 4, and 6 for the video. So starting off here with number 3. So they're giving us a triangle and they're identifying all the vertices by those three vectors for OA, OB, and OC. So first one is just find vector AB. So there's two ways to look at this. It kind of just depends on how it's presented in the problem. One way to look at it, like we've talked about before, is just the terminal minus the initial. So I can do B minus A to get that answer. So if I did vector OB minus OA, that would get my answer. The other way that you want to be able to look at this, and sometimes this is kind of needed, is just to write an equation. So remember, whenever you write just a kind of a basic vector equation where you're adding two vectors, you want to connect them. So for example, if I take vector OA, since that one ends with vector A, the one I add on to it needs to start with vector A. So that's where I throw in the AB. And the whole purpose of doing that is where if this one is ending at A and this one is beginning at A, that connects these into one big long vector from O to B. And so that's where I get the vector that is formed, which is OB. And so for this one, if we just kind of rearrange it a little bit, since I'm trying to find AB, I can get AB by itself by just subtracting OA over to the right, and that tells me that vector AB is equal to OB minus OA, and that gives me my setup for finding AB. So now if I just did OB minus OA, that gives me that setup right there. And so just doing some subtraction, you got your -2 minus -3, which is like saying -2 plus 3. You got your 4 minus 5, which is -1. And you got your 3 minus 2, which is 1. So there we got vector AB. We can do the exact same thing for vector AC. You can just look at it as terminal minus initial, or C minus A. So if I did vector OC minus vector OA, that would do it. You can also do it with an equation, and you might want to try one just for practice, because there are cases where you really need the equation. So if I wanted an equation that involves these guys as well as AC, remember, you want to create the link in the middle between where one ends, the other begins. So if I took vector OA, sorry. So if I took vector OA, and since that one ends with A, my next one will begin with A. And so now they're connected by that A, so it's all the way from O to C. Is that one right there. So again, the same thing. If I wanted to get AC by itself, I subtract that one over to the other side, and I'm looking at vector OC minus OA. So if I did this one minus this one, that's going to give me vector AC, and that's where we get the 10, -5, 2. And so you'll see, as with most problems, these guys are all connected here, so we're now using those two answers to do part C. So when they talk about the cosine of an angle, so two things we got to recognize on that. One is there's a formula for that, so we have that formula for the angle between two vectors in our formula packet. That was the one that looks like this. So here's our angle, our formula right there. The other thing you want to recognize is this problem is not asking you for an angle, it's asking you for the cosine of the angle. So this setup that you see is the cosine of the angle. So it's like we're stopping one step short of finding the angle, and we're going to be leaving it in this form. If it just said find angle CAB, well, then I would go the one extra step and do the inverse cosine of this to get the angle. But this problem doesn't ask for the angle, it says the cosine of the angle, which is what that setup gives you. So it's like we're stopping one step short of actually finding the angle for this one, because it left in the cosine. So again, if it left that word out and it just said find angle CAB, then I would do the inverse cosine of my answer to actually get the angle. So what would form angle CAB? So A is in the middle, so that's my vertex. So we'll put angle A right there. So to form angle CAB, you would need, if A is in the middle, I would need AC. So we'll call that vector AC. I would also need vector AB. So there's vector AB. So angle A is formed by AC and AB. And of course, we already have those two vectors from our two previous answers. So now working with, just to highlight it, so we got angle A, which is that guy right there. So on the top of part of the formula, it's just the dot product of those two. So you're doing your 1, negative 1, 1 times your 10, negative 5, 2. So you got your dot product on top, you have their magnitudes on bottom, and remember the magnitudes are their lengths, and we're going to kind of need that idea here in a minute in the later part of the problem. The magnitude of AC is also the length of segment AC, so that's something to keep in mind, but just throw in their magnitudes here real quick. So since I started with AB, let me do the magnitude of AB. So in this one right here, we have just a squared plus b squared plus c squared, all under the radical. Remember, you got that in the formula packet as well if you ever need to refer back to that. But if I did 1 squared plus negative 1 squared plus 1 squared, that all comes out to just be 3. So keep that in mind. The length of segment AB is rad 3. So that's something to keep in mind. We got that length right there. If I do the same thing now for AC, so I'm just squaring these guys, so 100 plus 25 plus 4. So now we have the length of AC as well, which is rad 129. So we're going to use those in the later part of the problem. So it's kind of good to know what those lengths are. Anyway, if you do some cleanup on that, so that's where we're coming out. So remember, for the product, dot product on top, you just multiply straight across and add your results. So 10 plus 5 plus 2 is going to give us the numerator. And then on bottom, you're just multiplying those two guys together. So for the numerator part, if we did that right, looks like it comes out to be 17. On bottom, if we multiply those two together, you got your 387. And again, we're going to stop there because it said the cosine of the angle. So we're not actually doing the inverse cosine to get the angle. We're going to leave it as the cosine of the angle equals. So that's what we're going to keep as our answer. So now moving forward, now we have the sine of the angle. So obviously we don't really have a formula for that within vectors. It's just the cosine of the angle. So it's like using now old information to get the sine of the angle. There's two ways to do it. I'll show you the way that's not already shown to you. In the worked out solutions, we're using a trig identity, the one that says sine squared plus cosine squared equals 1. So that works. You can just do sine squared plus cosine squared equals 1 and just solve that equation to get the sine of the angle, and that works. Let me just show you another way to link it to something that we've done in the past. If you just can think of this as like a right triangle. So let's see, we're working with angle A right now, so let me just put an A in there. So remember, what cosine does is adjacent over hypotenuse. So from angle A, I would have adjacent over hypotenuse. So there's the cosine. So if I use some Pythagorean theorem, I would figure out that this is rad 98. And if I want the sine of the angle, the sine of A does opposite over hypotenuse. So I got my opposite over hypotenuse. And so that works too. Obviously the trig identity and the Pythagorean theorem idea that I just used are linked together. That's where the trig identity comes from. But whatever one makes more sense to you is the one you can apply. We're now using all that information to find the exact area of the triangle ABC in simplified radical form. So really important that you pay attention to those directions. And I can't get a decimal on this. Not only can I not have a decimal, but I also need this in simplest radical form. So we got to do as much clean up as possible and leave it in exact terms. So moving forward, if I want to find the area of a triangle, so if you kind of go back to this guy as the triangle we've been working with, let me just connect the dots there to form the triangle. So if I want the area of the triangle, nothing up top would indicate that this is a right triangle. So I have to use my formula for areas of a non-right triangle, which is our 1/2 AB sine C formula. That works for any triangle. It doesn't have to be a right triangle. So for this one, whenever you do 1/2 AB sine C, the sine C, that C is the angle between two sides. So the A and the B in that formula have to be the two sides that form the angle, which are the two sides that we already have shown. So I'm doing 1/2 AB sine C, which we just figured out right here. This is our sine C, or sine of the angle. So if I just kind of plug those into our formula, I got my 1/2 times the two sides times the sine of C, which again, we already know the sine of the angle. Oops. We already know the sine of the angle is this. So remember, that's not the angle itself. It was the sine of the angle, which is what allows us to plug it into this. There we go. So there's our setup. All you got to do is multiply straight across, clean up as much as you can, just keep it in simplest terms, and that's going to be our answer for this one. All right, moving on to number 4. So in number 4, we got line 1 represented by that vector equation, and you got line 2, which is parallel to that one. So automatically right off the bat, we want to recognize that if they're parallel, that means they have the same, technically the same slope. And in this idea, this guy is the one that represents slope. So I know that they have to have this in common. Remember, think of this as y equals mx plus b, where b is a point, and the m is like your slope or your direction vector. Remember, in order for two vectors to be parallel, they either have to have the direction vector in common or at least a scalar multiple of this. So if I were to double these numbers or triple these numbers or divide all these numbers by 2, either way, that would make those answers parallel to this one. So we got that in common, and then it's passing through a point right here for line 2. So looking at what they're asking for the first part. So on the first part, it just says write down a vector for line 2 in the form. So I got to keep it in that form specifically. So we got to say R equals. By the way, if you put L2 equals, IB would actually mark you down for that, because L2 represents a line and not a vector. And so this one says write down a vector equation. So you have to have it in the form of a vector like R. You can't put L1 or L2 equals. You have to say R equals. They did say, and I heard this at a conference, they said that if you put L2 and then put R equals, that would be okay. But you got to have the R in there, not the L2. So we got the R equals. So for the point, for the P, we got to use the point that was given. So this is where the -6, -4, all that good stuff comes into play. I'm going to write that one vertically. You don't have to write it vertically, but I'm going to, just for simplicity's sake. So then I got my 88/3. So there's the point, or the P vector that they have in there, plus we have our variable of s, and then now we have our direction vector. And remember, the direction vector can just be the same as this one because they are parallel. If you put in any scalar multiple, you could have put in 6, 4, -12, and that would be acceptable as well. So any scalar multiple of this, remember 1 times this is also considered a scalar multiple of that, so we can just leave it as that. That would be the easiest thing to do. So a third line now is thrown in that is perpendicular to this one. So find the value of k. Trying to keep all that on there for you. So remember, if they're perpendicular, we know their product is 0. And when we say their product is 0, remember that all traces back to this guy. It's the direction vector. It's not a point. It's the slope. So we know that this guy times this guy equals 0. So it did refer us back to L1. So I'm looking at this one. Obviously, that's the same as the one we had for L2, so it didn't really matter which one you pick. But anyway, I know that basically that slope times that slope should equal 0. So we're just going to multiply those two together. So I got my -6, -3k. So I know that if I do that one times my 3, 2, -6, I know their product should equal 0. So remember, to do a product, you just multiply and add. So multiply straight across, I got my -18 plus -6 plus -6k. And I know all of that should come out to be 0. So now I can just solve that simple equation to get our answer for k. So that's where we figure out k comes out to be -4. Right here, so the lines L1 and L3 intersect at point A. This is something that we've done quite a bit in this chapter. We've also done it in worksheet A as a similar problem to this. Let's see how far is this one going here. So let me do this. So they're referring to line 2 and line 3. Sorry, I mean line 1 and line 3. So we're just going to be looking at those two equations for this one. So those guys intersect at point A. So I'm going to take my line 1, which we had way back up here. So line 1 was this guy. There we go. So I'm setting this one equal to this one. And the way we've done this in the past is, remember, you got to come out with either Q or T. It doesn't matter which one, but come up with one of those so that you can plug it back in order to get our answer for point A, which is where these two guys intersect. So one thing, again, a common mistake students often make on this is they'll solve for Q and T and then they'll be done. So remember, you're not solving for Q or T. You have to plug that back in order to come up with your answer for point A. So in this guy, we're just going to write two parametric equations that we can solve as a system of equations. If I had any zeros, I would use those, but we don't. So let me just use just maybe the first lines. So right here, I could do -2 plus 3q. And since I used the top line on that one, I'm going to match that up with the top line on this one. So I got my 4 plus -6t. So there's one equation, and then I just need one more. So I have my system of equations. So let's use the middle row, -3 plus 2q. And then I got my 3 minus 3t. So there's our two equations, and we just solved that like any system of equations. You can use substitution if you want. You can use elimination if you want. To use elimination, you would probably have to multiply maybe the bottom equation times -2 in order to set that up for elimination. I'm just going to do that since I already have those kind of written out here. So I'm going to multiply this bottom equation by -2. That's going to give me a 6 minus 4q. And that's a -6 plus 6t. So I took that equation, multiplied everything by -2 to get my new equation. And now if I just add those two equations together, my t's would get eliminated, and so I get my variable for q. So if I add straight down, I got my 4. This gives me a -1q. Let's see, right here we're looking at -2. My t's got eliminated, so now I have a simple equation to solve. So it looks like on that one we get q equals 6. Of course, I could plug that back in to get my value for t if they asked me to, but they did not ask that. They just wanted the coordinates of point A. So I can take my value for q, I can now plug it back in for Q in order to get point A. So if I replace Q with a 6, then for the first part, I have -2 plus 6 times 3, and that's going to give me my top number. Then I would do -3 plus 6 times 2 to get the middle number, and then 48 plus 6 times -6 to get the bottom number. And so that's where we get the 16, 9, 12 for point A. So let me just write that down here. So here we got point A. So I'll keep that for later. If you did solve for t, and you plug your value in for t right here, you should get the exact same results that we got on this one. That's always something you could do to check an answer. It just takes more time, so you would kind of save that for the end and make sure you got enough time for that. But that's something that I would do on a test before handing it in if I had some extra time. So there's our answer for part C. Now moving on to part D. So now where they're telling us that lines 2 and 3 intersect at point C, where BC equals this. That information comes in a little prematurely. We don't really need that information until we get to part E, because if I want to do vector AB, all I have to do is just the terminal minus the initial, which is B minus A, and we already have B and A, so I can just go right on into doing that. So to do part D, you're just doing B minus A. So I'm just doing those numbers minus those numbers to get AB. So that's all you had to do for part D. This information would now come in for part E. Obviously, we're involving C now at this point, so that's what we're doing here for the last part. So I'm going to skip the simple math that you would do there for part D, because you're just subtracting. So if you just did B minus A, you get AB. And you already had that information, so that should be pretty simple to do. Obviously, with a fraction, you can either do common denominators or just plug that into a calculator and let it get the fraction for you. So the last part here is now asking us to find the magnitude of AC. Remember, those absolute value brackets are always asking you for a magnitude. So we got to come up with AC and then find its magnitude. So for this one, remember, the same way approach that we took on this one, if I just do the terminal minus the initial, so AC is C minus A. And so for that one, I want to come up with a point C. So there's two ways you can get this vector. One would just be to do point C minus point A, but that would take a little extra work because we don't have point C yet. You could figure it out, but since we don't have that point yet, the better way would be to write the equation involving AC. So this is where I said earlier in this video that it really helps to be able to write an equation when needed. So for this one, remember, if I'm going to write an equation, on the left side I want to connect two vectors. So if obviously I need to involve vector AC. So what would create AC? So if we did vector AB, which we had in our other part of our answer, so if I could do AB, so that one ends at B, so the next part needs to begin at vector B. So now I have the BC, that's where this information is going to come into play. So AB plus BC equals AC, and we already have that information, so we just got to plug those in. So remember, the whole idea on this is because these two are connected at point B, that creates one big long vector from A to C, which is what forms him. So if we just plug in that information, so in part D, we came out with vector AB. That was the -22, -13, and 52/3. So there's our AB. Plus BC, and that was given to us right here. So that's where that information came in. So if I just add those together, that's going to give us AC. So let's just add straight across the top here. So -10, -5. And I could just do that in my calculator or create some common denominators, whatever is easiest. So looks like 1/24/3. So now we have our equation for AC. We got to go one more step. This one had the the magnitude brackets, so I now need to find the magnitude of AC. So this is where we then do the square of each term. And I'm not going to walk all the way through this because the last part of this is pretty simple, but if you square each term, so you got your negative 10 squared plus your 5 squared plus whatever that is squared would go here, and that would be it. So we can just simplify that as much as you can, and that would be your magnitude for AC. And this one did not specifically say to keep it exact, and it did not say rad form or surd form. So you can just put that one in your calculator and get a decimal. Just make sure you go to at least 3 sig figs in order to get the full credit for that. All right, moving on to the last one, number 6. Sorry, give me one sec. All right, so moving on for part 6, we got a parallelogram ABCD. It's given us some vertices for those, so we got the points for A, B, and D. So for the first one, find D. So just like, AD. So remember what we've done already in this video. It's just terminal minus initial, so we can do D minus A to get that. So if I just did D minus A, it's going to give us those values for AD. So that's where they're getting the 137 for AD. I'm just going to put that in there. So 137. So moving on, now we have vector AB. And again, same thing. You can just do B minus A to get that. So I'm doing B minus A. So if we do some subtraction on that one, looks like we get 414 for that one. So there's our vector AB. So now for this one, for the part 3 here, we got vector AC, and we can't just do C minus A on this one because we don't have point C yet. So this is where you really need to be able to write an equation. So we could say something like AB plus BC equals AC. So that's been a pretty popular equation all chapter long. So AB plus BC equals AC. Because again, remember those two connect at B, which gives us one big long vector from A to C, which is what forms him. So recognize that we do have AB, so I can plug that answer in right there. That's the 414. But what about BC? We didn't get one for that, but this is where you can recognize, we've done these in other problems, that BC is the same as AD, because they are parallel and congruent. So that allows me to take those numbers and plug them in here as well. So I can also put my 137 for BC, because that would be equal to AD. So I also got my 137 right there. And so now if I add those together, I got AC. So there's our 5, 4, 11. For AC. So for the next part here, they want me to now find the point for C. So one thing to keep in mind, remember that if we just did C minus A, then that would equal AC. So there's kind of a couple ways to look at this. I'll kind of do the way that I would have used. But again, I'm just kind of linking this back to things that we've already done. So I think that always helps. So remember that if I just do C minus A, that would equal AC. Right, because we're always doing terminal minus initial. So AC should be formed by C minus A. So if we just kind of plug in what we do know, before I do that, let me get C by itself. So we're solving for point C, so I'm going to add my A over to the other side. So that tells me that point C is equal to AC plus point A. And since I already had that information, I can now plug those in. So AC I can see is the 5, 4, 11. And point A, we already know is 3, 1, 2. So all I have to do is add those together to get point C, which is our 8, 5, 13. So that's where we would get point C. So that's what I would have done, simply because it links back to the exact same approach that I took on the first two parts. So there's our coordinates for C. So now moving on here to CI, we have AD times AB. So in this case, we are just multiplying those two answers together. I'm doing AD times AB, and we already got those guys over here, so I'm just multiplying those two vectors together. So I got my 137 times 414. Remember, always to do those, you just multiply and add. So I got my 4 plus 3 plus 28. So it looks like 7 plus 28 is 35. So there's their product. So find angle A. So angle A, you can see that angle A is formed by AD and AB. So when I go to use my formula for the angle between two vectors, I want to, angle A, I want to make sure I use the two vectors that form that angle. In the top part of that formula is their product. So if you look at the formula that we have for finding the angle between two vectors, the numerator is the product of the two vectors, which we already have. So there's my numerator. And the denominator is the product of their magnitudes. So if I did the magnitude of AD times the magnitude of AB, that's going to go on bottom. So the magnitude of AD, so kind of more of the same here for magnitude. So 1 plus 9 plus 49 is going to give me that one. And then 16 plus 1 plus 16 is going to give me that one. So we got a 59 right there. So anyway, multiply straight across and we get the 35 over 1947. So remember, for this guy, they are now asking for the angle. Which means you got to do the inverse cosine of all that in order to get the angle, which looks like so 37.5 degrees. All right, last part for D. Find the area of the parallelogram. So for this one, the only way to really do it with what we have is to break that parallelogram into two triangles. They're two congruent triangles, so if you find one, you just double your answer and you got the entire parallelogram. So for this one, see if I can draw this as best as I can. So I'm going to break it into two congruent triangles. So if I can just find the area of that triangle on the right, and just double that answer, and I got the whole thing. So this one's kind of similar to what we did earlier in the video, which is find the area of a non-right triangle. On this one, we need the sine of angle A in order to do that. We now know that the cosine is 37.5, so we got to use that to get the sine of the angle. So a couple things we got to do for this one here. First thing is since I'm going to have to use 1/2 AB sine C, I'm going to need the sine of that angle. We already know the cosine of the angle is this, so we need to get the sine of the angle. So like we talked about in an earlier problem in this video, you can use the Pythagorean identity and do the sine squared plus cosine squared equals 1, and you can solve for it that way. The other way you could figure it out is with some like a right triangle knowledge. So let's just say this is the angle that we're working with. I know that the cosine of that angle is adjacent over hypotenuse. So I could use Pythagorean theorem to figure out that third side. And that would give me rad 722. So now I can just say, okay, the sine of that angle is opposite over hypotenuse. So that's another way you could get it. So there's the sine of the angle. So now remember, to get this, I'm doing 1/2 A times B times sine C in order to get that. So we already know that those lengths are the rad 59 and the rad 33. Remember, length is magnitude. So those are the two lengths of the two sides. So I got my, remember, I'm gonna double this because I got two of these triangles. So I got my 1/2 times my two sides, which we already know. I guess I could have just put that number in there. It's always good to show your work on a test anyway, though. So I got my 1/2 AB sine C, and we already know the sine of at that angle is this guy. So that's where I can throw in that setup right there. So there we go. So I got two triangles to make up that